Imagine standing on a shoreline where more than 20,000 steel containers move every single day, each one carrying everything from smartphones and cars to coffee beans and clothing. The ground vibrates beneath your feet as towering cranes glide silently overhead, lifting loads heavier than entire houses with astonishing precision. You can hear the deep blast of ship horns, the constant hum of diesel engines, and the metallic clang of containers locking into place. But here's what nobody tells you. These ports are not just parking lots for ships. They are the beating heart of the global economy, and without them, modern life would grind to a halt in just a few days. Think about this. Nearly 90% of everything traded around the world spends part of its journey on a cargo ship, and almost every one of those products passes through a massive port before reaching your hands. From the outside, it looks like organized chaos. Yet every crane movement, every truck route, and every ship arrival follows a carefully planned system that runs 24 hours a day. What happens next surprised even experienced engineers, because behind every successful port lies an invisible network of technology few people ever see. The world's largest ports are engineering masterpieces built on land reclaimed from the sea, protected by massive breakwaters, and connected to thousands of kilometers of highways and railroads. Every minute counts here. A delay of just 1 hour can cost shipping companies hundreds of thousands of dollars as schedules ripple across entire continents. And this is where it gets truly extraordinary. Before a single container can move, millions of tons of raw materials must first become one of the greatest construction projects humanity has ever attempted. Most people never think about this, but every giant port begins far away from the ocean. High-grade iron ore comes from giant mines in Australia's Pilbara region and Brazil's Carajás mine, where the ore often contains more than 65% iron. These enormous rocks travel thousands of kilometers by freight train to steel mills, where temperatures exceeding 1,500 degrees Celsius transform them into the structural steel used in cranes weighing more than 2,000 tons each. Before a ship ever docks, the journey starts deep inside the earth. The concrete beneath every terminal hides another remarkable story. Limestone extracted from huge quarries in countries like China, India, and Turkey mixes with sand, gravel, water, and cement to create ultra-high-strength concrete capable of supporting cranes taller than 20-story buildings. Some foundation blocks weigh thousands of tons and must resist constant vibration, saltwater corrosion, earthquakes, and decades of non-stop operation. Imagine pouring enough concrete to fill entire city blocks just so one crane can safely move millions of containers over its lifetime. Now look beneath the pavement. Thousands of kilometers of copper cable, much of it refined from mines in Chile and Peru, power cranes, lighting systems, radar equipment, and automated vehicles. High-purity copper, often more than 99.9% pure, travels through underground conduits alongside fiber-optic cables that carry millions of pieces of data every second. Without these hidden networks, the world's busiest ports would fall silent almost instantly. Steel and concrete alone cannot survive the harsh marine environment. Specialized marine coatings, zinc-rich primers, stainless steel fasteners, and corrosion-resistant alloys protect every exposed surface from relentless salt spray and humidity. Some protective paint systems last more than 25 years, saving millions of dollars in maintenance while keeping giant cranes operating safely through storms, heat waves, and freezing winters. It's a hidden shield that almost nobody notices, yet everything depends on it. Building one of the world's largest ports also demands an astonishing environmental balancing act. Millions of cubic meters of sand are dredged from the seabed. Wetlands often require careful restoration, and advanced filtration systems prevent polluted runoff from reaching the ocean. Engineers constantly monitor water quality, marine life, and shoreline stability while expanding terminals that may cover thousands of hectares. The scale is almost impossible to imagine, but the biggest challenge still lies ahead. Because once every material finally arrives, the real engineering begins, and that's where machines the size of skyscrapers come to life. Now the transformation begins. Imagine walking into an assembly hall so enormous that several passenger jets could fit inside it end to end. Above you, overhead gantry cranes glide across the ceiling carrying steel sections that weigh more than a blue whale, while showers of bright welding sparks rain onto the factory floor. The air smells of hot steel and cutting oil, hydraulic presses rumble through the building, and every worker knows that a fraction of a millimeter can decide whether a crane will safely lift thousands of tons for decades. The process starts with thick structural steel plates, some measuring more than 100 millimeters, arriving from rolling mills. Massive CNC plasma and laser cutters slice each plate with incredible precision, using plasma hotter than 20,000 degrees Celsius, over 36,000 degrees Fahrenheit. Computer-controlled cutting heads travel at speeds of nearly 2 meters per minute, creating perfectly shaped components in just a few minutes while glowing streams of molten metal fall harmlessly below. Every cut must match digital blueprints exactly before the next stage can begin. Next comes forming. Hydraulic presses capable of delivering more than 10,000 tons of force, or nearly 22 million pounds, bend the heavy steel into enormous beams and box sections. Each pressing cycle lasts between 30 seconds and 2 minutes, depending on the thickness, while hydraulic systems operate at pressures exceeding 300 bar, or about 4,350 psi. The entire building seems to shake as steel slowly bends into shapes strong enough to survive decades of non-stop lifting in harsh ocean winds. Now comes one of the most demanding steps, welding. Hundreds of robotic welding arms work alongside expert welders, joining thousands of steel components into giant structures. Electric arcs burn at temperatures approaching 6,500 degrees Celsius, or nearly 11,700 degrees Fahrenheit, while automated welding heads move with steady precision at roughly 0.5 meters per minute. You hear a constant crackling sound, smell warm metal, and watch bright blue flashes illuminate the factory like lightning during a thunderstorm. After welding, every section undergoes stress relief and surface preparation. Giant abrasive blasting chambers fire millions of steel particles at high speed to remove rust, welding scale, and microscopic contaminants. Dust collectors roar overhead while workers in protective suits inspect every surface before multiple corrosion-resistant coatings are sprayed on. Each paint layer cures for several hours, creating a protective shield capable of surviving constant salt spray for more than 2 decades. Assembly now moves outdoors, where the true scale becomes impossible to ignore. Giant crawler cranes, each capable of lifting more than 2,000 tons, slowly raise enormous boom sections into position while crews communicate through radios and hand signals. A single lift may take 30 to 90 minutes, moving at only a few centimeters per second because even the slightest sway could damage months of work. Watching thousands of tons of steel float silently through the air feels almost unreal. The machinery comes alive when powerful electric motors, gearboxes, wire ropes, hydraulic systems, and computerized controls are installed. Hoist motors rotate at speeds approaching 1,800 revolutions per minute, allowing spreaders to lift containers weighing more than 65 tons with astonishing smoothness. Technicians carefully tension every steel cable, calibrate every sensor, and verify every electrical connection before the crane ever touches a shipping container. Most people never think about it, but every bolt tightened here protects cargo worth millions of dollars. Finally, the completed crane travels to the waterfront, where it towers above the harbor like a moving skyscraper. Engineers perform the first lifting trials using massive concrete test weights, carefully measuring every vibration, motor response, and structural movement. The entire machine moves with surprising grace, even though it weighs several thousand tons. But here's the mystery that keeps engineers awake at night. How do they know this giant will perform flawlessly for the next 30 years? The answer lies in technology more advanced than most people ever imagine. Step inside the control room and the atmosphere changes completely. The roar of heavy machinery fades into the quiet hum of powerful computers, glowing monitors, and thousands of blinking status lights. Every crane, truck, rail terminal, and cargo ship streams live information into one digital command center where operators can track equipment moving across hundreds of hectares in real time. And this is where it gets truly extraordinary. Before a crane makes a single move, artificial intelligence has already predicted the safest and fastest way to complete the job. Modern ship-to-shore cranes rely on hundreds of sensors working together like a nervous system. Laser rangefinders measure container positions with an accuracy of plus or minus 5 millimeters, while GPS, radar, LiDAR, and high-resolution cameras constantly monitor the crane's surroundings. Wind sensors update several times every second, automatically slowing operations when gusts exceed safe limits, while load cells measure lifting forces down to a few kilograms. What looks effortless from a distance is actually millions of calculations happening every second. Automation now handles many of the world's busiest terminals. Driverless automated guided vehicles glide silently beneath the cranes, following invisible navigation paths with an accuracy measured in just a few centimeters. AI vision systems recognize container identification numbers in less than a second, while automated stacking cranes place containers exactly where sophisticated software predicts they will be needed next. Imagine thousands of giant steel boxes moving like pieces on a perfectly choreographed chessboard without a single traffic jam. But no machine earns trust without passing relentless testing. Engineers inspect every critical weld using ultrasonic and magnetic particle testing capable of detecting hidden cracks smaller than 1 millimeter. Laser scanners compare finished structures against digital engineering models, measuring tolerances within plus or minus 2 millimeters across components stretching more than 100 meters long. If even one measurement falls outside specification, the entire section returns for correction before it ever reaches a port. Next comes the ultimate challenge: load testing. Massive concrete blocks and steel weights simulate real shipping containers until the crane lifts loads equal to or even greater than its rated capacity. Sensors record structural movement measured in fractions of a millimeter, while computers analyze vibration, stress distribution, motor temperature, and electrical performance. Every result must satisfy demanding international standards such as ISO, IEC, and specialized port safety regulations before the crane receives final approval. Even after passing every automated inspection, one final decision still belongs to experienced human experts. Veteran engineers climb high into the crane, listening for tiny vibrations, feeling subtle movements through the structure, and spotting details that computers sometimes overlook. Years of experience allow them to notice unusual sounds, unexpected flexing, or microscopic paint imperfections long before they become serious problems. It's a powerful reminder that even in an age of artificial intelligence, human judgment remains one of the most valuable technologies ever created. The results speak for themselves. Modern manufacturing keeps rejection rates below 1% for critical structural components, while predictive maintenance systems monitor equipment around the clock to prevent failures before they happen. Digital twins simulate years of operation in virtual environments, allowing engineers to solve problems long before the crane enters service. But here's the question that changes everything. Just how many of these incredible giants exist around the world, and which nations built the global trade network we depend on every single day? Now let's step back and look at the incredible scale of the world's largest ports. Every year, the global maritime shipping industry moves more than 11 billion tons of cargo, with container terminals handling hundreds of millions of TEUs, the standard unit used to measure shipping containers. Together, the world's ports form a giant network that keeps factories running, supermarkets stocked, hospitals supplied, and online orders arriving at your doorstep. If every container handled in a single year were placed end to end, they would circle the earth many times over. The port industry contributes trillions of US dollars to the global economy every year. The 5 leading container handling nations are China, Singapore, South Korea, the United States, and the Netherlands, together accounting for a substantial share of worldwide container traffic through their major gateway ports. Millions of people work directly or indirectly in shipping, logistics, manufacturing, customs, rail transport, and warehousing. Behind every container you see is an entire chain of skilled professionals working around the clock. Think about how far ports have come in just 50 years. During the 1970s, many terminals relied almost entirely on manual paperwork, diesel equipment, and radio communication. Today, artificial intelligence schedules crane movements, autonomous vehicles transport containers, and satellites track ships with remarkable precision from anywhere on Earth. What once took days can now happen in only a few hours, transforming global trade faster than almost anyone imagined. Did you know that some of today's largest container ships can carry more than 24,000 containers on a single voyage? That's enough cargo to fill entire neighborhoods if unloaded all at once. Did you know that the tallest ship-to-shore cranes rise more than 130 meters, making them taller than many city skyscrapers? And perhaps the most surprising fact of all, some automated terminals operate day and night with only a small number of people directly on the container yard, while intelligent systems handle thousands of movements every single hour. The next decade promises even greater change. Engineers are developing fully electric cargo handling equipment, hydrogen-powered terminal vehicles, AI systems that predict shipping demand weeks in advance, and digital twins that simulate entire ports before construction even begins. Renewable energy, automated inspection drones, and smarter logistics software will make tomorrow's ports cleaner, safer, and more efficient than ever before. The hidden world behind global trade is only just beginning its next revolution. From iron ore buried deep beneath ancient mountains to the towering cranes that shape the skylines of the world's greatest harbors, you've followed an engineering journey few people ever get to see. Every steel beam, every welded joint, every computer-controlled movement, and every carefully inspected component plays a role in keeping billions of people connected through global trade. The next time you watch a cargo ship disappear beyond the horizon, you'll know you're witnessing one small part of an extraordinary system built by human ingenuity, precision, and determination. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.